This is Frederic. My name is Piotr. We are leading SIG Instrumentation, one of those Kubernetes SIGs responsible for monitoring, logging, events, and those kind of stuff. This is deep dive, so we'll take a look in depth of what we are doing here. If something is not, is something like, if you don't understand something, just feel free to ask a question, because those might be, this presentation requires some other knowledge here. Yeah, so I don't expect this.
So if there are any questions, just feel free to ask right away. This is not super formal. If there's questions, yell them out. We'll hopefully be able to answer them.
Yeah.
Okay.
Do you want
you go for it.
So let's start with a quick recap from SIG Instrumentation intro. That was on Wednesday. I believe that there will be a video from this on YouTube as well. But we covered the kubectl top, kubectl logs, kubectl get events, and Prometheus format areas. So kubectl top is a tool that allows you to, it's a Kubernetes building tool that allows you to show resource usage of your containers running in a Kubernetes. So it's by default in Kubernetes. This is you can think about this like about this top unique style command. kubectl logs again is built-in Kubernetes. It shows you the recent logs from your container. By recent I mean something like recent 10 megabytes of logs, or this is the default, and you can configure this to a different value, but the assumption is that there is no historical logs, just the recent ones. kubectl get events, again, events are those lightweight messages in a Kubernetes that are explaining that something happened in the system, like for example, pod was scheduled on a node, and you can see those events using kubectl get events. Again, this gives you only, as there is a huge load on events, like if you have a big cluster, there is going on a lot of stuff. So there is a lot of events generated for such cluster. So kubectl get event shows you only the recent, the most recent set of events. The default is 1 hour. In order to have history, you need to archive them somewhere else. We also covered Prometheus format. So when talking about Prometheus, we can think about two parts of this Prometheus thing. One is the full stack monitoring solution, full stack open source solution that is under CNCF, that Frederic is one of the maintainers. So this is one piece. Another piece which is more universal is Prometheus metrics format. It's based, like it's inspired by Google internal metric format. And it's basically, it's becoming, or it is de facto the standard of exposing metrics in the world. Even if you are not relying on the Prometheus stack itself, you want to expose your metrics in Prometheus format. All Kubernetes system components expose metrics in this format as well. So you can easily integrate this format with other providers. I know that at least a few other monitoring solutions can scrape metrics in a Prometheus format. There is also work around standardizing, defining a standard monitoring format. This work is, what's the name? I forgot.
Open Metrics.
Open Metrics effort. So it seems that it seems that many monitoring providers, monitoring companies will agree at some point that, hey, this is a standard, and Prometheus format is a base for this standard. So this is what we did during the last meeting. Now I would like to show architecture overview, Kubernetes architecture, monitoring Kubernetes architecture overview. So here is the picture. So in Kubernetes, you have this core metrics pipeline, which consists of metrics API, the API, Kubernetes quality API that is available in Kubernetes API server that basically allows you to consume metrics. There is metrics server, the default implementation of this API. It's not a part of Kubernetes API server due to many reasons, including security one. We don't want to scrape from a master point of view. We don't want to scrape nodes for, like, there is this pattern that from master machine, we should not initiate a connection to nodes. And metric server, what metric server does, we'll see later in the presentation, but it basically periodically scrapes all Kubernetes nodes for metrics about the containers running on those nodes. Yeah. So this is coming for as a part of Kubernetes by default. Here are the consumers. So there is kubectl top, horizontal pod autoscaler, and scheduler. Like, this is not yet fully implemented. There are some works around using resource usage metrics in order to make better scheduling decisions. In addition to this, you need some third-party monitoring solution. It's basically up to the third-party monitoring vendor how to actually integrate with Kubernetes. But there is a way to consume data from this third-party monitoring solution. This is custom metrics API. That custom metrics API is defined as a part of Kubernetes, but there is no default implementation for this. Every single monitoring vendor, monitoring provider should have their own implementation of this custom metrics API. Of course, if they want to be integrated with Kubernetes. As for now, horizontal pod autoscaler uses metrics from custom metrics API to scale pods based on other metrics than just resource usage metrics. So this can be, for example, average request latency, or maybe number of requests, or length of your pub/sub queue, or maybe even something more sophisticated. So this is more or less the overview of architecture. Any questions so far?
Can scheduler go for custom metrics API?
Excuse me?
Can scheduler go for custom metrics?
Once again.
Can scheduler use custom metrics?
Yes.
Theoretically,
In
but,
theory, yes.
Not at the moment. I believe the initial work around resource-based scheduling is just looking at the resource metrics APIs, CPU, memory.
Yeah. So let's take a look what's going on a node. So on a node, on every single, so here are the pods running on a node, actually containers. On every single node, there is kubelet instance running there. There is a C-advisor, piece of C-advisor that is compiled into kubelet. C-advisor is a Google tool, Google open source tool to basically monitor your containers. It was even created before Kubernetes project. So it's compiled into kubelet. Kubelet exposes those metrics through summary API. So this is a Kubernetes API to gather those metrics from kubelet. And there is, of course, some parties, like it can be monitoring, it can be metric server, it can be third-party monitoring solution that scrapes summary API for those metrics. APIs. So basically there are three metrics related API. One is metrics API, the one that is that metric server implements. So this is basically basic resource usage metrics. So like CPU, memory, disk usage from the latest point in time. So there is no history, no application level metrics, no sophisticated system level metrics, just resource usage. This is there out of the box. So there is custom metrics API. Custom metrics API allows you to gather metrics from third-party monitoring solutions. The assumption with custom metrics API that the metrics is attached to a Kubernetes object. So we can have a metrics that is related to Kubernetes deployment, that can be related to Kubernetes namespace, Kubernetes node, pod, anything that you imagine. But the assumption is that this is this is metric related, like attached to Kubernetes Kubernetes object. And if you want to go outside of Kubernetes world, this means that you need a matrix that is not exactly related to any Kubernetes object. Like for example, you have some external system and you want to use those metrics in order to scale those workloads in Kubernetes, or you want them in any different way. There is external metrics API. Oops. There is this external metrics API. Basically, this could be just custom metrics API, but due to security reasons, those are separated, because in case of external metrics API, you are leaving this safe Kubernetes world and you know reaching something else outside of the Kubernetes. So metrics API, there is a default implementation. For custom metrics API, for external metrics API, you need a specific provider specific implementation. Metric server intervals. So basically metric server is registered in Kubernetes API server through this aggregated API server, aggregated API. So this is an effort that allows you, this aggregated API is an effort that allows you to basically register your custom API server in Kubernetes API server, and you will basically be able to reach the objects in exactly the same way that you can reach Kubernetes objects. Yeah. So metric server is registered in Kubernetes API server, so that you can get metrics in the same way like you can get just pods. Yeah. And as I mentioned, metric server periodically scrapes nodes for those metrics. So what's going on in the metric server? So metric server periodically periodically scrape summary API endpoints on every single kubelet, then perform some aggregation. It enrich those metrics with metadata. The metadata comes from API server. So there is watch on the API server. And we send there is a single request for all containers running on a particular node. So it's not that we are asking for every single container, but for a batch of containers, for a batch of metrics about the containers running on a particular node. This is due to performance reasons. And thanks to this, metric server scales pretty well. It uses something between 3 and 4 megabytes of memory per monitored node. And if you specify large enough memory request, it easily scales to 5,000 nodes. So in order to monitor 5,000 nodes, you need to just specify memory request to 20 gigabytes. But that's not that much for the 5,000 node cluster, yes? So what's going on what is the flow of data in metric server? So here are sources. So here are nodes. There is source manager that basically initiate scraping metrics from every single source and make sure that in case of timeout, we are not basically stuck, but rather we are just moving forward. Then there are processors that are enriching the scrape metrics with metadata, like those labels, node name, some others. It also aggregates some metrics. So for example, in order to aggregate metrics about node, we need to aggregate metrics from all pods running on this particular node. Then the data are stored in in-memory storage and can be reachable through metrics API. So this is pretty common architecture for many monitoring systems. Custom metrics API adapters. So there is a few of them as for now. There is one for Prometheus, there is one for Stackdriver. During this conference, I learned that there is also a Datadog specific. Does anyone know that whether there is one?
There's a sysdig one
There is also a SysDig one.
There's a SysDig one that is being open sourced very shortly, and yeah, Datadog is working on theirs.
Okay, okay. So, you know, this API was introduced quarter or two ago. So there is already a few of such adapters. The more are coming.
Yes.
Question?
Just to make sure I understand correctly, that would mean that I can access my Datadog metrics through the custom metrics API.
Yes.
Yep.
Yeah.
Yes. So this is custom metrics API adapter.
Yes.
Could you go back 2 or 3 slides where you one more? The status summary API. Does it provide you aggregate data or data about the current state of the system?
The current state of the system. By aggregated data, you mean aggregated across time?
Yes.
No historical data, just the current state of the system.
Yeah.
What's the interval of getting the data from the metric server?
Excuse me?
And what's the interval in which the metric server
It's by default 1 minute.
1 minute? So you always get kind of a snapshot every minute.
You are getting the average CPU, average memory usage from the last 1 minute.
But then, in order to get the average, you would need to have time aggregated data.
But
So,
this is always 1 minute.
This is a normal monitoring problem, right? It's a count for CPU. You get CPU time spent by a container, and then you can do a rate over time, and you know the amount of CPU time that something had used. Well, for memory, you only get the current status.
You can change the collection interval of metric server though, so
Yep.
if you would like to have more precise
Yeah.
time snapshots, you can tell it to collect more frequently. There is kind of a lower bound of where you can set it due to the way we have CAdvisor configured inside kubelet. That lower bound is roughly 30 seconds, depending on how much CAdvisor chooses internally to fuzz its collection intervals. It's a long story.
Yeah, so
But you can drop it down to 30 seconds.
yeah. So
However,
maybe-
if
Go
sorry,
ahead.
if you like don't use this for monitoring purposes, use this for what it was built for like kubectl top and for some HPA purposes. But if you actually want to monitor something, this doesn't store any data, right? So it always just has the latest sample in memory. So when you want to do that, use an external monitoring system that actually stores historical data, like Stackdriver or Prometheus or whatever. Insert your favorite monitoring solution.
Yeah. So coming back to this monitoring architecture, this is this core metrics pipeline that is mostly for Kubernetes system components to operate, and you need more. This is not provided by Kubernetes. You just need to install your some kind of extension, some additional monitoring solution in order to have history, for example.
Yes.
One more question to this metric server and my custom monitoring system. Fiddlescript, it's scraping the nodes, and if I want to store the data, I have, for example, Prometheus scraping the node also. You were talking about adapters for the custom metrics API, but the metrics API basic could be implemented also, so you can replace the metric server with example Prometheus.
Yeah, so Solly and I have actually been talking about exactly that.
Yeah, it's on my list of things to make that easier. I'm currently in the process of doing a refactor of the internals of metric server to simplify them, because there's some legacy code that was left over when we ported metric server from Heapster. And so as part of that, I'm going to make the interface between like serving the resource metrics API more distinct from like the actual underlying internals of how metric server keeps stuff in memory and does the collection. And so hopefully once that's done, we'll be able to look at pulling that interface out and making it possible to do stuff like serve the resource metrics API out of Prometheus.
Because you're right, like Prometheus, if you're using Prometheus or any other monitoring system, it already collects this data, right? The metric server is about being able to provide a consistent experience to every single Kubernetes cluster out there. but it is still an interface, the resource metrics API. So totally, any monitoring system that has this data can implement it.
So even as for now, you can there is nothing that blocks you from replacing metric server with your custom implementation of this. Similarly, like you can replace scheduler with your custom implementation, you can replace controller manager. Basically, any single Kubernetes components, maybe except from API server and kubelet, can be replaced by something custom. Yes. The question is whether you want to do this. And for metric server, I don't see motivation to do this because metric server, as long as it's a part of the default Kubernetes distribution, guarantees you that the metrics that it exposes are exactly the same as kubelet collects, as basically kubelet uses internally to perform, for example, eviction operations. So you have this consistency across multiple components. So if you see using kubectl top that you are reaching the resource limit of your pod, you can expect that kubelet will basically soon kubelet can evict this particular pod. Yes, and if you replace this by something custom, there is no guarantee that it will collect exactly the same data in exactly the same intervals. Similarly, for horizontal pod autoscaler, you have the same problem. Yeah.
The kubelet expose Prometheus metrics.
Yes, yes.
Already, so
As for now.
if you scrape
The long-
Prometheus and feed them
Yeah.
to the metrics API, it should be the same.
It should work just fine.
The summary API is served off of the same internal data sources that the Prometheus metrics are served off.
I don't know. I guess we maybe disagree on this, but I think what I think of the metric server is like the canonical implementation. It definitely gives you the correct implementation, whereas anything else is like, it's like the metric server is what we as SIG Instrumentation definitely make sure that it works correctly. With the vendor implementation, we can't oversee everything. That was the problem with Peepser in the first place, right?
Yeah, of course, I get.
Yeah.
Thanks.
Ask a
Yeah.
high-level architectural question. How does Istio service mesh and the monitoring piece that brings fit into this picture, if any? Because that seems to be one of the big drivers for adopting Istio in the community. We talk to people. Does it fit in? It's completely dependent.
So that's definitely something that fits more in the custom metrics solutions. As like a piece of metrics that are collected by some other system. I don't think we can ever build something like the metric server for something like that.
I've talked a little bit with the Istio folks in the past, not a ton, I need to get back on that, about having a better story though for how the metrics interplay between each other. But for now they're mostly independent sources, but it would be great eventually to be able to say, let Istio consume metrics for its load balancing purposes from the custom metrics API, and to have us be able to consume service metrics from the metrics that they collect and stuff like that.
You sort of end up having Prometheus and Grafana and
Yeah.
sort of the same.
I would say that Istio falls into source of data for third-party monitoring solution.
Definitely.
As far as I know, it's integrated with a number of solutions, of monitoring solutions. Yes.
Are
So
you interested in like doing auto scaling based on that, or just monitoring?
As a user, right? I mean, I hear, okay, there's, the one side I have, sort of like the metric API, which might change it from heap service, whatever, but then I'll have the metric API on one side, which can get consumed by, let's say, Prometheus, Grafana as sort of the canonical stack that most users. And then on the other side, I have Istio, which, by the way, everyone is saying it's great for monitoring.
Yeah.
I
So
think as a user, it's very important that we have an answer for that, I guess.
yeah. So Istio is definitely something that just produces metrics, right? So it's absolutely something that some monitoring system consumes. It itself doesn't.
That's why you see Prometheus, Grafana.
Exactly.
It can also consume metrics.
It also
Right.
consumes for load balancing.
Yeah, but actually, like Envoy does that internally mostly.
Okay. let's move forward. We
Yeah.
have only 10 more minutes. This is a great discussion. We should have made this longer than 35 minutes. So here are the internals of metric server. Here are adapters, Hipster. Hipster was integrated with a number of solutions. There is a few of them here. There is 15, something like around 15 integrations with various monitoring solutions in Hipster. Hipster also have a few APIs that are non-versioned, that are not Kubernetes quality, just some APIs who someone implemented in Hipster, just Hipster grew organically. So there are some problems with Hipster. One is that it's hard to maintain. Another one is that those APIs are not the Kubernetes quality API. They don't have well specification and so on. So basically the solutions for this is to duplicate Hipster, and this is something that we are doing right now. The first piece, this piece should be replaced by something provider specific. Yeah. This piece will be replaced by, is already replaced by metrics server. Yes, there is metrics API that is well-defined API, and there is metrics server, which is an implementation of this. As you may know, basically the first version of metrics server was basically a trimmed down Hipster. Yes, because it does more or less the same work underneath, but it doesn't require, it's not integrated with third-party solutions. There is less API exposed, and so hopefully it will be easier to maintain. Any questions on this? Yeah, sure.
This is kind of maybe doesn't fall under your purview, but maybe you've heard something. It's probably a question for SIG UI or something. But I think Kubernetes dashboard uses metrics in Hipster for displaying those pretty graphs in there. Do you guys know if that already has been or will be changed? So Kubernetes dashboard uses metric server instead of Hipster.
Yeah, they filed a bug as soon as I filed the official deprecation notice pull request. There was almost immediately a bug created. We had talked to them in the past.
I'm aware of this problem. Also, this is also the reason why, we talk about deprecating Hipster during Contributor Summit in 2016, so it was a year and a half ago. So there were some ideas around this, nothing concrete. There was, but we let the UI folks know that this is a problem, and they haven't done anything so far. So now we need to be, let's say, more aggressive in this area and fill the official deprecation policy. In the meantime, we migrated HPA, we migrated kubectl top to metrics API, basically.
Yeah, the important part for us was that everything that is critical for a Kubernetes cluster to actually work to be migrated. Hipster has a number of things, right? So someone uses some of that for sure. So there's no way to make everyone happy in this. So at some point we just need to move forward and deprecate this and make some solutions switch faster than they naturally would have. It's just
at the same time, this is open source. The code is there, so it's not that this will just disappear.
Yeah.
We'll just stop, fixing more issues with this. But, this is not Google Reader story.
Okay. Yeah, I don't need.
Your turn. Oh, sorry.
Okay. Yeah. I don't know how much time we have left.
Pretty few.
Not a lot. So I'll try to make this quick. So about a year and a half ago, actually almost 2 years ago, kube-state-metrics was created by Sam Gods. I don't know if I pronounce his name correctly. Hopefully. And at that point, I was talking. I didn't know about kube-state-metrics, and I was talking to Matthias from SoundCloud because kube-state-metrics was already a component that had Prometheus-style metrics, but actually neither Matthias nor I knew about kube-state-metrics. And Matthias and I, we were at the SoundCloud office, and we were like, "What's missing? You're a really advanced and knowledgeable Kubernetes user. What's missing?" And he said, "What's kind of weird is that they have all these really nice metrics, but I keep using kubectl to like do production stuff and see if stuff actually works correctly. And that doesn't make a whole lot of sense because we want to automate these things, right? We want to write alerting rules for this, be able to dashboard these things. So we want to have an actual metric source for cluster state. And there wasn't really a part in Kubernetes where we could say the API server should expose cluster state, or the scheduler should, the controller manager should. The point of metrics, especially in Prometheus world, is that we expose white box metrics, so something about the component itself. And for none of those, cluster state really fits because it looks at Kubernetes as a whole, not as a specific component. Then we both did some research, and we did find kube-state-metrics, which had like 2 metrics at this point. Which for when Sam actually built this worked awesome for him. He had like a node metric and a deployment metric. And that's exactly what he wanted to alert on. And it landed in like the Kubernetes organization because he was like one of the really early on contributing people. And so he just created a repo. When we found this, it had for like half a year already hadn't had any commits. So I think these were maybe one of the, I think these were the 2 metrics that he had at this point. And we were like, cool, this is exactly what we want to do. We have like here, we have replicas that we are expecting from this deployment, and how many we actually have. And that's something that's a condition we can alert on, right? So that's really cool. Yeah, 2 metrics untouched for half a year. We're like, we are SIG Instrumentation. We need to use this. We need to pick this up. So that's exactly what we did. And now fast forward to about 7-8 months ago, in August of last year, we were discussing how we can move forward to GA kube-state-metrics. So we had a bunch of discussions with folks from Google, and basically we said we need to go through all of the metrics that we have, because at this point we had added a ton of them. We were at around 100 metrics at this point. Basically Piotr just said we need to run a load test in order to be able to GA this. So we did. And that actually turned out to scale super well. Apparently, I heard at this conference, it doesn't anymore, but we'll run new scalability tests for the latest version and figure out what's wrong. So yeah, but at this point it did. And so we decided to GA it. Yeah, so now, fast forward to today, we have around 531 commits. This was like a week ago. I took off these statistics. We have 145 metrics and 72 contributors. I think that's pretty cool. So yeah, nice. But let's actually look at how this thing worked. So when we picked it up from Sam, the way this worked is that we had this cache, and this is a pretty normal component when you look at Kubernetes architecture. There's these things called informers, and you have like a cache that's automatically populated by the Kubernetes API. You do a watch and you do a list and a watch, and then you get all of the events basically, and you keep the cache up to date that way basically. And then at this point in time, every 10 seconds, the code would go ahead and sync every 10 seconds all of this data from like deployments and stateful sets and whatever objects we were watching into the Prometheus metrics registry, because Kubernetes kube-state-metrics is about exposing them in Prometheus format. And then whenever Prometheus came along, it just built the metrics output from the metrics registry, and that's fine. Well, actually, this is not fine, because what we did here is that we created all these metrics with these deployments or whatever the object name is, and we set the value. And the problem with this is that over time, even when these objects disappear here and the cache properly cleans them up, they actually are still in the metrics registry. And there's no real way to clean this up properly. Today there is, but anyways, this architecture was not the correct one for the problem at hand. So we removed this, and instead, whenever Prometheus comes and scrapes all these metrics from the kube-state-metrics, it actually builds these metrics on demand. So it then goes through all the objects in cache, and then builds the metric output. And then we don't have this problem anymore that there are stale metrics that about objects that actually don't exist anymore. So that's cool. Except that if you paid attention, we're actually, now that we have Kubernetes clusters with like 5,000 nodes guarantee, this actually can, the cache itself can become pretty large, but that's pretty well optimized at this point. At least from Kubernetes point of view, we probably can't optimize a whole lot more. But every time Prometheus scrapes this information, we build this giant Prometheus output and at least double the memory usage, and it's also pretty heavy on CPU to do this. So this is the current architecture, and we have some ideas on how to improve this. And basically, I've been bouncing some ideas with some people, and I think this is sort of what pretty much everyone agrees on. Basically, we're just going to take the cache part out of this equation, because the metric output we for sure need to build, right? That's the whole point of this project. But we are basically swapping out the storage of the cache to be the metrics registry directly. And this has a couple of nice properties, which is that we don't build all the Prometheus objects every time we scrape, but the metrics registry just basically prints to an I/O object and be done with it. So hopefully this will solve the scalability issues we have right now. If not, we'll have to see what else there is. And yeah, if that doesn't work out entirely, there's additional optimizations that we can do here, because at the point of building these metrics, we actually only need a very small subset of all of these objects, because only a small number of things in Kubernetes objects can actually be translated into metrics, right? A metric is a number, and something like an image or something like that is not something that's very helpful to be a metric, but a replica is. So we could partially just parse all of these things when we receive them from the API server. And that should also reduce the footprint of the data we need to hold in the first place. So yeah, that's pretty much it for kube-state-metrics, but I do think we have run out of time.
We are out of time, so maybe I'll just show. Aren't we? Can we have 2 more minutes? Okay, cool, thank you. So this is high-level logging architecture overview. So here is kubectl logs, net through master machine, queries for logs from kubelet, Docker, and that's it. So how does it work in details? So if a container logs to std or std out, this log is written to a file. There is some work around renaming those files, but I think the current state is that there is this container ID in the path, so that you can figure it out which particular container this file is from. And when you query this goes through kubelet to this particular file. And if you want to have third-party logging solutions integrated, you just need to you just need to deploy logging agent to a node and read and configure logging agent in the way that it reads those metrics from files. Yeah, this is more or less this. Thank you. You go ahead.
Yeah, there was this bug, mentioned bug, which tracked the logging pipeline, which a week ago was closed by this bot that closes the bugs, which suggested that there was some like a logging pipeline. Now, logging is not very sexy and not very popular, but sometimes you get required to gather.
I know, I work on this.
But sometimes you're just required to gather everything, regardless. They don't ask you. So what's the state of that? Because it's
I don't know which particular bug you are talking about, but
The problem that you dump the files, it's fine, but there are problems sometimes that the Kube does not create the links.
oh,
And
so
we
this
use
can.
those. That was nice. And there is the part that.
Oh, this sounds like a serious bug then.
it's easy.
Why it was?
It's black, it's bad.
So by the way, for people who are filing bugs, if that bot comes along and says like there was no activity on this in 20 days, where I'm going to close it and it's still a bug and you know it's still a bug, don't be afraid to like be like, no, shut up, bot.
Yeah.
Like
So it's risky.
there's commands you can give to be like, this is not a stale bug, I'm still experiencing it. Like if you're still experiencing it, go ahead and do that. Like say it's not stale, pipe up on the bug, say you're not experiencing it, and or come find one of us in SIG Instrumentation and poke us and be like, you really got to work on fixing it.
Yeah.
Yeah, so just if you open this bug, then just reopen it. If not, then comment on it and make sure, if not already, to comment Kubernetes/SIG Instrumentation on it, and like we're all in that team, and then we can make sure that this is resolved. Obviously, this shouldn't be the case.
Go ahead. So maybe we can do some questions offline. So we are done. Thank you.